In this video, I'm going to show you how to create basic graphs using Microsoft Excel and a set of sample data. So what I have here is a data table. My independent variable is the concentration of copper 2 sulfate measured in moles per liter. My dependent variable, which appears on the right-hand side, is voltage, measured in volts with an uncertainty of 0.01 volts. I took 3 measurements for the same concentration and calculated an average for each data point. So when we construct a graph, we don't plot every single measurement that we made. Typically, we want to plot just the average. So there are 2 ways to do that, and I'll show you both of those ways today. So the first way is to select your values for your x-axis, that's your independent variable, and to select the average without selecting everything else in between, you can press and hold the command button on a Mac or the control button on a PC. So if you press and hold that button and then select your values for average, you've selected only those 2 columns. Now, typically in science, we look at the relationship between variables, and these 2 variables are both continuous, so we will use a scatter plot. So once you've selected your x values and your y values, simply create a scatter plot, and you get something like this. And that's the beginnings of the graph that you should have. One of the first things you should do is create a descriptive title for that. It helps to just say y versus x, so whatever your y is. In this case, voltage versus x is our concentration of copper sulfate. So concentration of copper sulfate. If you are very particular about details, probably want to use a subscript for that 4. Okay. So there's our basic graph, but it's still incomplete. One of the things we need are descriptive labels for our axes. So what you can do is click on your chart area. This should take you to chart design. Add a chart element, and let's add axis titles for the horizontal axis and also for our vertical axis. Again, what is on our x-axis is our dependent variable, so that would be the concentration of copper sulfate measured in moles per liter. Do the same thing for your y-axis. This represents voltage with an uncertainty of 0.01 volts. So notice the labels for my axes are simply duplicates of the labels for my columns in my data table. That's a good template to go by. One thing you should also check on your graphs is scale. You don't want, what I mean by that is you don't want a graph that is too short and wide. You also don't want a graph that is too narrow and tall. A nice way to gauge appropriate scale is having more grid lines here. That will also help you identify points in between data points if you have to read your graph later on. So you can right-click on your horizontal axis and add minor grid lines. Do the same thing for your y-axis. Right-click, add minor grid lines. And ideally, those rectangles is what they look like now. They should be more square-ish. So let's manipulate this chart area a little bit. and make them more square-like, just like you see on graph paper. Right, so if you're investigating a relationship between two variables, you probably want a line or curve of best fit. So in order to do that, you can just right-click on your data points and select Add Trend Line. Now you can play with the different options and choose the one that best fits your data. If you're already familiar with error bars will really help you select the appropriate fit. I'm not showing error bars here, I'll show that in another video. But right now a linear fit looks pretty good. I really don't like dotted lines if it's a line of best fit, so you can change that, I believe, over here for the dash type. Make that a simple solid line. Probably don't want it to be too thick either. You can even just make it black. Your data points, you should also check that they're actual points and not, sometimes the default for some spreadsheets is to use these large diamonds or squares or whatever. And so this is a graph with data points, so those should look like points. Another thing you probably want to do is extend your best fit line so it fills your entire chart area. So you can do that by formatting your trend line. You want to create a forward or backward forecast. So again, play with this a little bit. Like say, for example, if I put 1 in there, it just looks really weird. So if I go back to 0, which is what we had before, I probably want it to go over to 0.6. So I'll put 0.1. Do the same thing for the backwards. Now notice how it changed the maximum for my horizontal axis. You can change that as well. If you click on that axis and change the maximum to 0.6, which is what we had before. Great. And so for some relationships, sometimes the reason why you want to extend your best fit line is sometimes the y-intercept means something. Sometimes you want that y-intercept to be 0, so if it isn't 0, you have to explain that in your discussion. Now another thing that you can do is display the equation for that line on our chart. So click Display Equation on Chart. If this is a linear graph, you also want to display the r-squared value on the chart. R-squared value is an indication of how appropriate a linear fit is for this set of data. In this case, we have 0.9798. That's a pretty good r-squared value for a linear fit, and you can see that the linear fit really is it fits quite nicely to our data points. You would get a maximum r-squared value of 1 for a perfect linear fit. Another thing that you can do is change y and x to represent the actual variables that we're working with. So our y-axis corresponds to voltage, so I can just put V. Our x-axis corresponds to concentration, so I can put C in there. And so the equation for our line gives us more information about the relationship. We know the slope of our line, it's 0.6367. We also know the precise value of our y-intercept, which is 0.217. So that's how you create a very basic graph using Microsoft Excel. If you need to put error bars in your graph, I have another video that will show you how to do that.